Okay, good evening, everybody. So we're going to talk about fractional exponents for a little bit, and we're going to do this a little bit differently. I'm going to ask you guys to pause it during different times of the video, and I really encourage you guys to pause it and try and do what I ask you to do, and then hit play again so you can then see what the answer is. But this is one of those opportunities where I want you to see what you would come up with on your own, and then see if you agreed with me. This is a very cognitively challenging concept today. So we're going to try and do it a little bit different than I've taught in the past, a little bit of discovery, and then, of course, as always, add fifth color as needed. And then at the end, hopefully we'll wrap it up and you'll see the connections. Okay, so what I want you to do first is I'm going to put some additional answers on the notes here, and then I want you to pause it. And I want you to solve for the different variables. So in the first one you're solving for x, second one you're solving for y, and the third one you're solving for z. And I think you'll see it's not too terribly difficult. Okay, so the first one here, 5 to the 4th to the x is equal to 5 to the 24th. The second one is 5 to the 28th. And the third one is 5 to the 3rd. So go ahead and hit pause right now and see if you can solve for x. Okay, hopefully you had a chance to hit pause, and I'm going to go ahead and show you how I would have solved it. So what I would do for this one is I would say that this is raising a power to a power, and when I raise a power to a power, I multiply. If you didn't know that, or you didn't write down the file type and the technique, it's a great idea to put that into your notes right now in your fifth color, because it is raise a power to a power and multiply the exponents. So that means that this one would be 5 to the 24, which is equal to 4 times x, like that. And then, of course, if I'm going to solve this equation right here, I'm going to need to divide this by 4, and then I divide that one by 4. And you're like, can you really divide exponents? Of course I can. I can do anything I want as long as I do it to both sides. So let me clean that up real quick here. So that would be a 4 there underneath. So then I get 5 to the 6th, because that simplifies out and that simplifies out, equals x. Therefore, x is equal to 6. And if I come over here and plug it back in, I get 5 to the 4 to this times 6, and that of course is 5 to the 24th. Now, I don't think probably any of you did the work that I did over here, but we certainly should be able to. You should be able to manipulate those numbers just as I did. So if you need to, you can. Okay, so then this one of course is going to be equal to 7y. Divide this side by 7, divide that by 7, and you get 5 to the 4th. Therefore, y is equal to 4. Okay? And again, same thing down here. I'm going to say this is equal to, and raising a power to a power, multiply, 6z. Divide both sides by 6. And you're going, that's kind of weird. This would be 5 to the 3 over 6 is equal to 1/2. Therefore, z must be equal to 1/2. And that, of course, is correct, what z is equal to. If I put a half right here, 1/2 times 6 is 3. So it works. Okay, let's take a look at the next slide. Very similar thing being done here. I'm going to put up the answers for this, and then you guys press pause, and then you see if you can tell me what x equals. I would appreciate it if you could show the work as I did on the last one. That would be, of course, best. Alright, so this is going to be 5 to the 16th. This one is going to be 5 to the 5th. And this one is going to be 5 to the 5th. Whoops, and I put a 1. There we go, 5 to the 5th. Okay, go ahead and press pause, and then see what you come up with. Again, try and show the work you can. Okay, hopefully you had a chance to do it. I'm going to go ahead and do it the way that I would. I would say that this is 16 must be equal to 8x. Divide this side by 8. Divide this side by 8. So then I get 5 and 16 divided by 8 equals 2. Therefore, x would have to be equal to 2 because those simplify out. So x equals 2. Same thing here. I'm going to say this is equal to 10y. Divide both sides by 10. And I get 5 to the 1/2. Therefore, and that's equal to y. Those simplify out. Therefore, y is equal to 1/2. And again, that's my solution. And finally, this one would be 5 to the 5th equal to 5t. Divide both sides by 5. Those simplify out and make a 1. Those simplify out. Therefore, this is 5 to the 1st, which equals t. Therefore, t is equal to 1. Okay? So we should be able to manipulate the numbers there, understanding the power to a power, multiply the exponents rule, and we should be able to solve for those variables. Okay, keep that in mind as we move to the next slide. Okay, so here we go. We have 5 squared to the z, and I'm going to give you a solution to that, which is equal to 5. Therefore, we should be able to calculate what x is equal to. So, what I need to remember on this one is that there's an exponent of 1 right here. So, if there's an exponent of 1, then that would be equal to 2x. And then, of course, I divide both sides by 2. There we go. Divide both sides by 2. So then this would be 5 to the 1/2. Therefore, x must be equal to 1/2. So I'm going to go back over here and I'm going to write it again with 5 squared to the 1/2 now. Now I've replaced the x right here with what I found x to be. Okay, so we take a look at this. We know some things about 5 squared. What is 5 squared? Well, 5 squared is equal to 25. So 5 squared is equal to 25, so 25 to the 1/2. Well, I saw up here a second ago that 5 right here, 5 squared to the 1/2 was equal to 5. That was the original example right here. Okay, so I said 5 squared to the x equal to 5. So this is 5 squared to the 1/2 is equal to 5. So that means 25 to the 1/2 must be equal to 5. So if 25 to the 1/2 is equal to 5, the only way I can get from 25 to 5 is that means if I take the square root of 25, of course that's equal to 5. So then what that means is that this fractional exponent right here must be the same thing as a square root symbol. And in case that's the fact, and in fact that's the case. When you have a fractional exponent, it means you're taking a square root. So I have the square root of 25 is equal to 25 to the 1/2. Okay, so let's take a look at the next slide. So once again, I have 5 squared to the 1/2. So when I have 5 squared to the 1/2, that's equal to 25 to the 1/2. And then 25 to the 1/2 is equal to the square root of 25. So the square root of 25, of course, is 5. So what we need to understand is that when you have fractional exponents, what that means you're taking a root. In this case, it's a square root. There are also things called cube roots and fourth roots. But if you have 1 over 2, that means you're taking the square root of a number. Okay? All right. So what I want you to do on the last slide is to take a look at these and see what we can come up with on these. And again, I'd like you to press pause and see if you can do it before I can. And then I'll put the answers up here in just a second. Okay, so go ahead and press pause and tell me what you think the answer to each one of these is. Alright, that probably was enough time. So then I could rewrite this as the square root of 16, and the square root of 16 is 4. I can rewrite this one as the square root of 49, and the square root of 49 then of course is 7. And the last one here, I can rewrite this one as the square root of 37. We don't know the square root of 37, therefore that's my answer. So, fractional exponents are the same as square roots, no different. Okay, talk to you guys tomorrow and we will go over some other examples.